Hello everyone, मैं हूँ राइनी and today we will be studying atmospheric circulation and weather system. So let's see in this chapter what are the things which we are going to cover. So we will be seeing the conceptual part of this chapter. There are a lot of definitions, there are a lot of physics terms here. So we are not going to cover that. You will be getting this PDF and you can go through the physics terms through this. Today we will be dealing with some concepts which are very important when it comes to your prelims and mains as well as interview. So geography is, you don't have to mug anything in geography. If you can relate with the actually diagram, if you can relate with actual phenomena, then you don't have to mug anything. Okay. Obviously the diagrams, when it comes to the diagrams, the important diagrams are very important, especially for your mains point of view, but concepts are very important along with that pictographic memory of those diagrams when it comes to prelims. So let's see what we are going to study. We will be doing studying atmospheric pressure, vertical variation pressure. Then we will be dealing with Franz extra tropical cyclone, and all these things. We will be studying about the pressure gradient, how the pressure fluctuates from one place to another. Then we will see how the winds are like flown from one direction to another. All these things we will be covering in this chapter. So here we see the simple definition. What is your atmospheric pressure? So in our 11th and 12th standard, this book is also of 11th NCERT. So in 11th standard we have studied that the weight of the column of the air contained in a unit area from the mean sea level to the top of the atmosphere is called atmospheric pressure. So this is a lump sum your definition, but actually what is atmospheric pressure? The amount of pressure, the force which the air puts on the object in the given area. So that is your concept. So going forward with this, we can see the pressure decreases with height. So this is a very important thing, that pressure decreases with height. Suppose this is your hill. Okay, so the pressure here will be much higher than the pressure which you will feel over here in this region. So the pressure decreases when you go higher on the elevation side, and this happens in the lower atmosphere. What is the lower atmosphere? The lower atmosphere is your 1 to 3 kilometers in the atmosphere range, like from sea level. If you take 1 to 3 kilometers, 4 kilometers, that is your lower atmosphere. In lower atmosphere, we see that as we go above, as your height increases, the pressure decreases with the elevation. Vertical variation of pressure. In the lower atmosphere, the pressure decreases rapidly with height. That's what we discussed. So that's obvious. Let's see. There is another important point. The vertical pressure gradient force is much larger than the horizontal pressure. So one more point here is that although the vertical pressure gradient is much higher than the horizontal pressure gradient, but still we see that though we don't feel any upward movement of the air. Do we feel that? Have you ever experienced that there is upward movement of the air? No, right? This is because generally balanced by nearly equal but opposite gravitational force. So as the upward force is coming, equal gravitational force is pulling it. So we don't see any wind which is moving in upward direction or downward direction. So mainly the winds are in horizontal direction. Now the horizontal distribution of pressure. Small differences in pressures are highly significant in terms of wind direction and velocity. So even if there is small change in the wind direction, you can see the distribution of pressure in horizontal direction. So now what is isobar? Isobar is another important term. Isobar are all the places which are having equal pressures. Okay, these are your isobars. So these lines, these circles which I am drawing, these are your all the places which are having your same pressure. World distribution of sea level pressure. So when it comes to world distribution, we will see that there is the world. Okay, let me draw this for you. So this is your world. So this is the equator region, right? So we have to draw it little bit bigger. Okay, because we have to see a lot of things here. So suppose this is your world and this is your equator. Okay, so we have seen that in the equatorial region we have equatorial low pressure. In the equatorial region you have low pressure. Then in the region which is your 30 degree north and 30 degree south, there you can see that the high pressure area is there. Okay, they are your subtropical highs. And again in 60 degree north and south, you will see your low, subpolar low. And again in the polar region, there will be high pressure. So this is the distribution overall. We will see the diagram further and you will be able to know it. See, this is the diagram here. Yeah. So here we can see that this is your low pressure area, then again high pressure area, then again low pressure area, and you're in polar high pressure area. Now why this low pressure and high pressure is happening? The fundamental is very easy. See, if we consider the globe as to be, as you can see here, but actually what we have seen that our earth is slightly tilted on its axis, right? This is its axis, but it's slightly tilted on its axis. But if we take our earth as this, and if we consider that the rays are coming in this direction, vertical direction, and this is your globe and the rays are coming in vertical direction, then in that case the ITCZ is lying on the equator, and that's why there is a lot of heating happening in this area. Okay, there is a lot of heating happening in this area, and because of huge heat there is a low pressure, and when there is a low pressure, so the wind rises. Okay, when there is a lot of heat, the wind rises, and as the wind rises in this area, low pressure gets created, and from this high pressure area you will see that air is gushing to this region. So wind always travel from a high pressure area to a low pressure area. Okay, so here you will see that it's gushing from a high pressure area to equatorial region. So this is your high pressure area, this is your low pressure area. Because of intense heating, again you will see the same falling of low pressure area happening in this region, subpolar region, which is your 60 degree north and south latitude. Eventually you will be able to figure it out, and this diagram, students, is very important when it comes to mains point of view as well. Forces affecting the velocity and direction of winds. Now we will see what are the factors which are affecting the velocity and direction of the winds. So you already know that the air is set in motion due to the differences in the atmospheric pressure. Yes, we know that wind always blow when there is a difference in pressure. If there is no difference in pressure, then you will not have this wind blowing from one direction to another direction. So the air in motion is called wind. The forces exerted by the rotation of the earth is known as Coriolis force. So this Coriolis force is also acting. Suppose this is your earth. Okay, so the earth is moving, right? The earth is moving. So when the earth is rotating, it will have a force called Coriolis force. Okay, the horizontal winds near the earth's surface responds to the combined effects of your pressure gradient force, the frictional force, Coriolis force, and in addition gravitational force. So again this becomes your important concept here. So whenever there is a horizontal wind moving from one place to another, there are four forces which is acting upon it. These forces are the pressure gradient. What is your pressure gradient? High pressure, low pressure, then the frictional forces, Coriolis force because of the rotation of the earth, and the gravitational force of the earth. So till here I think everything is clear. Everything is clear. We'll go further. Yeah. The difference is atmospheric pressure produces a force. So when there is a difference in atmospheric pressure, suppose here we have low pressure and here we have high pressure. So there is a difference. So a force starts acting in this scenario. So the rate of change of pressure respects to distance is the pressure gradient. The pressure gradient is stronger where the isobars are close to each other and weak where the isobars are apart. So can you see this diagram? Yeah, so in this diagram we can see that here the isobars are very close, right? So here the pressure gradient will be higher, but here you can see the isobars are far apart. Suppose the isobars are like this, okay? So they are far apart. So in this case the pressure gradient will be weaker. And when the isobars are like very close to each other, almost merging, here you will see that the pressure gradient force is higher. It affects the speed of the wind. It is greater at the surface and influence generally extends up to elevation of 1 to 3 km. Over the sea surface, the friction is minimal. So if you see the pressure gradient force, this will be within your 1 to 3 km zone itself. Okay. Heading forward, we will see the rotation of the earth about its axis affects the direction of the wind. This force is called Coriolis force. We know that. What is Coriolis force? We know. And Coriolis force is directly proportional to the angle of the latitude. It is the maximum at the poles and is absent in the equator. So what is your Coriolis force? It will make an angle with the latitude. Okay. So your Coriolis force will be minimum at the equator and maximum at the poles because it's making angle with the latitude. So the angle here which it makes will be almost 0. And the angles which it makes over here will be higher, 90 degree. As you head towards your polar region, the angle will be higher. So when the angle will be higher, the Coriolis force will be greatest. So at the equator, the Coriolis force is minimum and at the poles, it's the highest. So here what we can see is the pressure gradient force is perpendicular to the isobars. The higher the pressure gradient, the more is the velocity of the winds and larger is the deflection of the direction of winds. So all these things are like, we can deduce all these things. So one more thing, students, the wind circulation around a low is called cyclonic circulation. Around a high is known as anti-cyclonic circulation. So wind circulation around a low, like if there is a low pressure and there is wind circulation going on, it is called cyclonic circulation. You just have to keep this some things in mind. It's very easy. So you can just keep these things in mind. And another, when the circulation is around the high pressure area, it is called anti-cyclonic circulation. The direction of winds around such systems changes according to the location in different hemispheres. So in different hemispheres, we will see that there is change in direction, and according to that, the change in the direction of the winds is there. See, this diagram will be showing you how what is happening here. Here you can see that there is low pressure happening. Okay, this is low pressure. Low pressure means what happens, students? The air ascends. Okay, the air goes up. When the air goes up, there is vacuum created over here. You get a vacuum in this area. And when you get a vacuum in this area, the adjacent air will come and flow. And then you will get this cyclonic condition. Okay, this is your cyclonic flow. But when there is a region where there is happening a high pressure, air will descend. It will not flow upward. It will descend. The air will descend. It will come down. So when the air will come down, then you can see that it will have an anticyclonic flow. So this is your concept which you have to remember. Yeah. So the general circulation of the atmosphere we will see now. So the pattern of planetary winds largely depends on the latitude variation of the atmospheric heating. Obviously, see what does it mean? Suppose your earth is tilted, right? It's not like this, it's tilted on its axis. So when it's tilting, it's rotating and it's rotating and it's also revolving, right? It's rotating and it's revolving also. So when this earth is rotating and as well as revolving, in that case the sun rays are not exactly same every time. It will be like shifting its place. Sometimes it will be in this region and sometimes it will be in 30° north and 30° south region, and between that you will see. So if the sun is moving, you will see that the ITCZ, that is the prime location where the sun is actually falling vertically, will be falling between your 0 to 30° north and 0 to 30° south. So it will depend on the latitude variation of the atmospheric heating, the emergence of pressure belts. So pressure belts, we know that in equatorial region it is low pressure, then again your subtropical high, then again polar subtropical, then you get this polar region 60° may again you get this high, and then again low and then high. So this is the occurrence. The migration of belts falling apparent part of the sun, the distribution of the continents and ocean. Even the distribution of the continents and ocean matters, because we know that how the isobars is formed, students. It is formed where we see equal presence of pressure. So suppose this is a place, this is a region, okay. Here there is a mountain, then there is an ocean, then there again is a mountain. So it will variate, okay. The variation will be there. So in this case, you will be seeing the difference in between the pressure as we go up in that particular place. The rotation of the earth. So these factors are actually converting your planetary winds pattern. These are contributing to your planetary winds pattern. Latitudinal variation of the atmospheric heating, emergence of pressure belts, the migration of belts falling apparent part of the sun, and the distribution of the continents and ocean, and the rotation of the earth. Again, these factors are very important. You have to keep in mind. These are very sensible factors also. You can always think whatever we have like discussed till now, that obviously when the earth is rotating, that is going to affect the pressure and the wind. When there is heating difference, that is going to affect, because again the low pressure and the high pressure area will be created. So in that sense, these are the factors. So now about your ITCZ. Okay. So the air at the intertropical convergence zone rises because of the convection caused by high insolation, and a low pressure is created. So ITCZ, intertropical convergence zone, is a place where you get the maximum insolation of the sun. Okay, maximum insolation of the sun you get in this region, and when you get the maximum insolation in this area, you will get low pressure because the air will ascend. Air will ascend. So now we will see about the cell formation. Okay, again this is very important. The cells are very important. When the circulation is there, you will see that there is cell formation. So the easterlies from the eastern side of the equator converges in the intertropical zone. The circulation from the surface upwards and visible is called cells. Such a cell is called Hartle cell. So there is something called Hartle cell, and there is something called Ferrel cell, and there is something called polar cell. Okay. For knowing this, we have to again go to this your this diagram. So this diagram will tell you. So this is your Henle cell. I'm sorry. So this is your Henle cell, which is getting formed in the ITCZ region to the 30° north, 30° south, and then you have this Ferrel cell and then your polar cell. Okay, and why these cells are formed? Again, because of these winds which are coming. Okay, this trade winds. Trade winds are getting attracted to the equator. We know that the equator region has your heated region, and when the air gets heated, it goes upward. So air from the high latitudes which are cooler will ascend and come to this region, and there the trade winds are coming and they are creating this Henle cell. And same the opposite phenomena is happening above this between 30° north and 60° north, and respectively in the southern zone also, and there you will find this Ferrel cell. Let's see what they have written here. In the middle latitude, the circulation is the sinking cold air that comes from the poles, and the rising air in the blows the surge tropical high. At the surface, these winds are called westerlies and the cell is called Ferrel cell. So the winds which you get there in that region is a westerlies. So again we will go to this diagram and we will see that the winds which blow over here, these are called your westerlies. Let me do it with another figure. So these are your westerlies which moves like this, and in equatorial region the winds will blow like this, and these are your easterlies or trade winds. Okay, so equatorial region between 30° north to 30° south you will have your trade winds, and above that in 30° north to 60° north and south respectively you will have your westerlies. So students, we will be dealing till here today. We will continue our class tomorrow as well. We will continue. Thank you.